Yeah, this is a follow-up on a cosmic ray video that was produced. It was a highly technical, and I just wanted to summarize it for many of you. We've been trying to prove there's a brown dwarf in the solar system. We've trying to prove that we know exactly where it is. And if we look at the earthquakes that we vectored last year, we put this thing about the orbit of Saturn and headed out of the solar system at about 40 degrees above the ecliptic, headed into the direction of Uranus. We vectored earthquakes, and we earthquakes that cannot be corresponding with any other alignments, and we vector those with a theoretical object where we think it is, and lo and behold, here comes the earthquakes once again, this time involving Venus. Venus, when it passed between the Earth and the Sun, created a significant earthquake and acted like a large body alignment. Then, when it squared up with where we thought this brown dwarf was, we experienced a rash of quakes once again. And so again, these quakes cannot be explained with a Jupiter alignment. The Mars alignment is not 90 degrees, and sometimes those aren't very geo-effective anyway. Now, so we think there's a brown dwarf out there. We think we've tracked it through this solar system. It really wasn't hard. We just followed a orbital path that was suggested by one of the top astronomers on planet Earth, and lo and behold, earthquake sequencing, magnetosphere anomalies, all seem to indicate that he was right. And so, but a brown dwarf, it's hard to look for the signs of a brown dwarf when people try to obscure what a brown dwarf is in the first place. And that's the case. You try to do research on brown dwarfs, you watch videos on brown dwarfs, nobody's going to tell you and mention the word helium. But when you talk about a red giant, you're talking about a helium fusion star. And they're very large stars. They make heavier elements through the fusion process. The fusion process itself releases tremendous energy. And we've been talking about the interstellar medium, the cloud. It's not a cloud. We maintain it's coming from this brown dwarf. It's more of a stream or waves coming from one direction, and then when it's thing made a circle around the sun in just a year, it left cosmic rays throughout the entire solar system. The sun, not having CMEs, is not keeping out any cosmic rays to begin with, so to have something that creates cosmic rays inside our solar system is really spelling trouble for all the planets that have and harbor life. The telltale signs, therefore, of a brown dwarf is helium, and there's much on the helium, only mainstream is not going to cover it. It's very scientific, and most of the stuff that we have shown you, the really true scientific articles coming from Europe and Japan and the rest of the world on this interstellar medium, this cosmic ray cloud, this hot bubble, they call it a bunch of different things, but a hot helium bubble, and you look up helium focusing cone, and that's when neutral particles get focused just like any other object into the sun. And we covered what happens when the helium hits our magnetosphere, when it hits the sun's magnetosphere, when it hits the sun's cosmic rays and irradiance, when it hits the sun's protons, when there's these collisions and interactions, when the protons steal electrons from the neutral helium. These are tons of different particle interactions that can happen just between helium and the sun. Outside helium. Now the sun puts out helium too. Now, but it's finally been disclosed that in this solar wind that we've been covering and talking and screaming about and getting censored over and being attacked because of it, the implications are horrendous for planet Earth. And therefore, when we found that they finally updated the interstellar wind, because Everybody's studying it and the composition, and it's out there. But this is what they found: carbon, nitrogen, oxygen. Carbon, nitrogen, and oxygen are found in stars that are pretty big, that can fuse carbon into heavier elements sometimes, but fuse helium into heavier elements. When you go heavier element on a helium fusion, you get beryllium and lithium. Those can decay back into helium. Each process requires energy or releases energy, and the incredible amounts of energy coming from particle collisions and particle interactions and electrons is quite diverse, and when you add it all up, it's quite intense for what we're used to. So we find carbon, nitrogen, and oxygen in this interstellar medium. It's almost dead certain proof that there was once a very large star out there, because remember, this carbon, oxygen, and nitrogen is part of a cycle we called the carbon, nitrogen, oxygen cycle, or abbreviated the CNO cycle. Very common in astronomy terms, the CNO cycle, where carbon and nitrogen are fused to form heavier elements, and oxygen then degrades and forming carbon again, and so that cycle releases tremendous amounts of energy, and once it starts in a star, it's difficult to turn off. The CNO cycle in the stars would then indicate a large star, but when you look at the magnetism that this thing is exerting, and the difficulty it is in seeing it, and the fact that the planets aren't terribly perturbed, then we know that we're dealing with not a full-size red giant. We're not dealing with even a full-size brown dwarf. The smallest brown dwarf is around the size of Jupiter, so this thing has a magnetic field roughly that of Jupiter. This thing meaning brown dwarf. Planet X. Planet 9, Nemesis. How can something that doesn't exist have so many names? So it's important that we don't argue about the origins. It's important that we understand what the implications are of going through and seeing these extra particles in the solar system. Extra particles means extra energy, extra interactions, extra collisions. Those collisions release tremendous amounts of gamma radiation. So the fact that they find these elements in the star then pretty much supports what we've been telling you for the last how many years? Come on, everybody say it, because it's been so long I can't remember anymore. We know it's had collisions in our solar system. It's left evidence of itself everywhere in our solar system. Its physics tells you it's here, and they have found it a long time ago, once infrared spectroscopy was implemented. But the other thing that was quite astonishing was they were finding neon in the downstream portion of the interstellar wind. And that's kind of amazing. Neon is created through the fusion of carbon, and it exists in some isotopic forms, and it's part of our atmosphere. So if we have something that is made from incredibly big, huge fusion stars like a red giant, if we have all of those things existing within our rocky core in our atmosphere, how did it get here? How did the helium being released from volcanoes get here? How did our volcanism get here? How does... all of it's explained by a collision between a brown dwarf and a massive planet. downgrading the brown dwarf to 70% of its original size, and the same holds true for the icy, rocky planet. So what this means is that the sun's brilliance and whiteness and hotness and intensity is not going away, not this year anyways, and it's responsible for the apocalyptic fires and the record surface temperatures, land or water. It accounts for why we are seeing people measuring extreme ultraviolet C on the ground, which still NOAA contends that the ultraviolet C does not make it to the ground. Yes, our ozone. Anyways, so, and yes, those chemtrails, the geoengineered mineral oxides, those do reflect some of that ultraviolet C. Just to let you know. Until then, until next time.